Hello and welcome to the show. Today, we're diving into the fascinating world where nature meets nanotechnology. We're talking about lignocellulosic biomaterials, essentially, the stuff that makes plants strong. Think wood, straw, or bamboo husks. These materials are everywhere, totally renewable, and form the structural backbone of the plant kingdom. But they aren't perfect. Natural materials like wood have limitations. They soak up moisture, can decay or be eaten by insects, and often aren't as strong or durable as plastics or metals. This holds them back from being used in more demanding applications. So, how can we make these amazing natural resources even better? Enter nanotechnology. Scientists are finding ways to infuse these plant-based materials with tiny particles, nanoparticles, to create new composites with dramatically improved properties. Why do nanoparticles make such a big difference? It comes down to their incredibly small size. Because they're so small, they have a massive surface area compared to their volume. This means they can get deep inside the porous structure of wood or plant fibers, even reaching into the tiny spaces within the plant cell walls themselves. This close contact allows them to interact strongly with the natural components, the cellulose, hemicellulose, and lignin. Plus, nanoparticles often have unique properties of their own. They might be magnetic, conductive, or even kill microbes, and they can lend these abilities to the bulk material. How do scientists get these nanoparticles inside? There are several clever methods. One advanced technique is called in situ synthesis. Here, they actually grow the nanoparticles right inside the wood or plant material. Imagine soaking wood in a special chemical precursor, then triggering a reaction to form magnetic iron oxide nanoparticles directly within the wood structure. This gives fantastic integration. Another common way is impregnation, basically soaking the material in a liquid containing pre-made nanoparticles, sometimes using vacuum or pressure to help them penetrate deeper. You can also simply coat the surface with nanomaterials for things like UV protection or water repellency. There are even methods using mechanical force, like ball milling, to blend materials and form nanoparticles simultaneously. Interestingly, we can also process plant materials themselves into nanoparticles, like nanocellulose or nanolignin, and use these to reinforce other biomaterials. What are the results of adding these nanoparticles? We see significant improvements. Mechanical strength, stiffness, and hardness can be boosted considerably. Durability goes up, with better resistance to moisture, decay, and insects, meaning materials last longer. And we can add totally new functions. We mentioned magnetic wood, which could be used for electromagnetic shielding. By adding conductive nanoparticles, we could create sensors or components for electronics from wood. Using silver nanoparticles can make materials antimicrobial, useful for filters or even medical applications. Nanoparticles can also act as catalysts, helping to break down biomass more efficiently for biofuel production or improve thermal stability and fire resistance. We can even use lignocellulosic nanomaterials as tiny carriers for the slow release of things like pesticides in agriculture, making them more targeted and eco-friendly. This field is moving fast. Researchers are working on making these infusion processes cheaper, greener, and scalable for industry. They're also studying the long-term behavior and environmental impact of these nano-enhanced biomaterials. The goal is to precisely engineer materials for specific jobs. Imagine high performance, sustainable building materials, advanced packaging, components for energy devices or electronics, all derived from renewable plant resources. This nano-infusion technology is a key step towards a circular bioeconomy, where we rely more on sustainable, plant-based resources. It's truly about making the most of nature's ingenuity, with a little help from the nano world. That's all for today's look at enhancing natural materials with nanotechnology. Thanks for tuning in.